Hi, everyone. My name is Taso Arima. I am the CEO and founder of IperionX, and here to talk about our developments in the titanium supply chain, both on the titanium metal side, but with our scoping study on the titanium mineral side of the business as well today.
So nice to see you again. We spoke about 6 months ago, and we tried to speak 2 months ago, but you were running around the country, and we didn't quite make it. In the last 6 months, there have been a huge amount of developments. Do you want to just kind of recap with your kind of the key milestones that you've met in the last 6 months? That'd be really useful.
Yeah, over the last 6 months, we've made a lot of progress across both sides of our business in an effort to reshore the titanium supply chain from end to end, from ore to metal. We have been developing our titanium minerals business, which is our Titan project in West Tennessee. It's a large scale, it's the largest titanium mineral resource in North America. It has a significant endowment of rare earth within it as well. And we completed a scoping study on the Titan project recently. It was recently released probably about a month ago. And we've continued to progress that. We have a mineral demonstration facility, which is essentially a pilot facility being developed down there. We can talk about that as well. But then on the titanium metal side of the business, we've significantly advanced the production of our titanium metal powders. Eventually, we will produce titanium metal powders from the titanium minerals coming from the Titan project. But today, we produce titanium metal powders from scrap. We are the only company in the world which can produce a 100% titanium metal powder that is 100% from a recycled product. And we've been ramping up that, and we have a significant amount of customer integration and interaction around that part of our business. So a lot going on, a lot to happen in the next throughout the rest of the year, and we're really excited about the rest of 2022.
When I wanted to get in contact with you 6 weeks ago, it was about, or a month ago, it was to discuss the scoping study, because that had just come out. So I think it was published on the last day of June, and you put out a presentation in the first week of July. And here we are, as you say, about a month later. Now, just if we can just focus on the scoping study for now. We'll cross over to the metal side
Absolutely.
of the business, but let's deal with the simple chunks, or do things one at a time. So the scoping study in Canada or the US, it would be called a preliminary economic analysis, a PEA. It chucked out a pretty punchy NPV number, NPV8 of 692 million at a 40% IRR. And the Capex was $237 million for over, to kickstart a 25-year mine life.
Yes.
The highlights that you kind of talk about are the fact that the NPV is almost 3 times the size of the Capex. Can I just ask, when it came to getting that Capex figure, how difficult was it, given the inflationary environment, the way that prices were moving around? What was the process that gave you the confidence to put in ink a Capex figure?
So it's a good question, Merlin. So for us, we have in our team people that build a lot of operations here. So our incoming Chief Operating Officer, Scott Sparks, who I've dealt with in all my career, going back to the coal industry. He actually builds projects, and his team, Minerals Technologies on the ground, who have operations and are building a mine right now. We went direct to the source. So this wasn't going to a database and pulling up numbers. This was actually going and getting quotes for most of the major equipment, good budgetary estimates in this environment. So this is up-to-date budgetary estimates of what we expect the capital to be. So, we did see inflationary pressures, but I think for us, we didn't see it as much. It's not a $1 billion project. There's a lot of construction labor on the ground. There's structural steel there, but there's not as much as you would think in, say, some other projects. So we're very confident in that number.
A mineral processing plant's a relatively simple thing, isn't it? Because it can be separated on gravity.
Yeah, it's very simple. So we put in a 30% contingency into that capital number. Includes a 30% contingency, and quite a bit there for EPCM as well. So the actual mechanical equipment, the actual erection, the actual structural steel and all that across both the wet concentration plant and the dry mineral separation plant is not that large. And it's quite simple. You're talking about gravity separation, so you're essentially pumps and spirals, so you can get the slurry up to the top of the spirals and allow the gravity to just do its work to separate out the heavy minerals from the light minerals. And then in the mineral separation plant, you've mainly got just magnetic, electromagnetic, and electrostatic equipment. You don't really have, big vats for leaching or any materials or construction materials that are expensive. Like you don't need to use any high corrosion resistant, high nickel alloys or anything like that, which would have driven the price up substantially if it was like that.
It's about just under 10 million tons per annum, so it's not a particularly huge throughput compared to other mineral sands globally. It fits into the spectrum. It's not an outlier.
But at the same time, Merlin, it still is a large from the products that we produce. It still is quite large because it is high grade, relatively high grade compared to new projects out there. So you compare us against, say, the Coburn deposit, which is an excellent deposit being built and is going to be commissioned this year, over 3% in our operation. So although we would be half the size, would be a similar sort of size in terms of mineral products, maybe a bit larger.
What are the physical properties of your ore? Are there clays in there? Are there lots of fines? Is it the test work you've done so far? Does it handle well?
Handles quite well. We actually am I able to share a screen here? So
yeah, absolutely.
Let me show you. So we have actually built a little mineral demonstration plant here, and I'll pull it up here for everyone. So this handles the fine clay. So we have two units within the McNary sand. We have an upper McNary and we have a lower McNary. In the upper McNary, we don't have much fines, much clays. Mm-hmm. It's probably around 5%, maybe less. In the lower McNary, you can have up to 20% fine material. Not an issue in this part of the world. We find we have a lot of water in this part of the world. And we built this little facility here probably 2 months ago to do our feasibility samples, and we're actually adding a spiral separation, a spiral circuit to this side of the operation. So this mineral demonstration facility was built to help us progress the development of the project, but also to show the community that it's just water and gravity that does the job. But we haven't found any issues with the clays. There's been operations, our Lucas operations in Virginia had 30% clays in them. I'm not too sure how much clays were in the operations in Georgia and Florida, but they're high as well. It's not uncommon for North American style deposits to have some clays in it. We have not seen any issues from our separation out here because of clays.
Will the mining be conventional mining, or will it be a hydraulic mining?
No, we'll go conventional mining out here. What we showed and what we targeted in the scoping study was, or what we assumed in the scoping study was truck and shovel with mobile mining units. So the mobile mining units, similar to what is used by Kamua's operations in Florida and Georgia, would move along as the operation progresses and would slurry the ore and send it to the wet concentration plant. We will look at dose trap and then slurry to the wet concentration plant as part of the pre-feasibility study to look at and do a bit of a trade-off there. It could be either or.
So dozer trap would be that you would shovel into a
push into a trap. Maybe we might, and then from there, we would then put it into slurry and then send it off to pump it out into the wet concentration plant for separation.
And those options can be reviewed during the pre-feasibility stage.
Yeah, sorry, Merlin. We're actually reviewing a range of options right now, ahead of going straight into pre-fees. So we've got our pre-fees ready to go, but we've stopped right now, and haven't stopped. We've paused from progressing to the pre-fees to evaluate a few things. Size. So we went large to showcase how big this could be initially, and mind you, we could potentially build a few of these. We could see a few of these styles of operations throughout West Tennessee. I'll just bring up one other thing for you here.
Because
Just
your
because,
initial plan is on 10% or 5% of the resource, whatever it is.
yeah, it's on about 30-40% of where we are. So this is Mount Canary Sand throughout West Tennessee. These are our properties, and we've drilled all throughout here and continue to see the similar sort of concentrations of heavy mineral sands. We continue to pick up land throughout here and throughout here. But eventually, over the next, say, decade, you could have an operation here, you could have an operation here. There's definitely an operation in here and here for sure. And then out here, we've been getting good grades and continue to pick up some land. So you could see one, two, three, at least three, if not four operations of that scale out here, in my opinion. But we got to do the work to see that. But it's looking very positive. The other thing we've stopped and paused at as well, Merlin, is, show the 10 million tons, but we could start off smaller to get going. We think there's a couple of very really positive things there. We can move through permitting quick with a smaller operation, or faster, and showcase to the community that this can be a sustainable operation with the active reclamation and rehabilitation behind us. And we can get our product out to market quicker and for lower capital cost. So we're evaluating that, and at that same time, we're evaluating the dozer trap operations. So we will, as we move into pre-fees, that evaluation will complete in the next. It's an internal evaluation, but it will complete in the next probably month and a half, and we will then move into our pre-feasibility study.
Well, traditionally, a pre-feasibility study is the time when you run with a series of different scenarios, and it's the it's the kind of the maturation of your ideas, both at this so kind of combination of strategic from the board level with the input from senior executives, but also the kind of the cost implications, the NPV options you've got, and it's where those two meet, and you feel you've got the optimal strategic approach along with the kind of the most robust set of numbers, which isn't always the highest NPV, but it can be, as long as as
long as it gets out there.
Now,
Now, I do think the NPV will improve because there's some projects or some opportunities we're looking at now which can significantly improve NPV, especially, and we'll be coming out to the market with that in the near term on the mineral side of the business. I think we've also got opportunities on the rare earth side because we produce almost 1 million electric vehicles worth of NdPr a year from this operation. We've already seen interest from the automotive companies in the US for something like this, and we have the relationship with Energy Fuels, which means we can separate and develop a full American rare earth oxide supply chain with relatively low capital. We wouldn't have to put in any more capital than that. But for us as well, I'll go back to my team has built operations and builds operations right now. My chief operating officer and the key people within my team, Jonathan Lord, my VP of geology and land, they all came out of the sector of building and operating operations. So we sort of know where we want to go, but the idea of developing a more thorough initial phase or initial stage and then stepping it up and putting that into the pre-fees earlier on was really more got to do with allowing us to apply and go for permits early. We have a very good relationship with the state government and the communities at the moment, very strong relationship with the communities. And we think that there's an opportunity. We have done already our baseline studies and our work, our groundwater monitoring, our jurisdictional determination of where our streams and wetlands are in the area. And so we think we can move forward with an application for a permit this year. And what we've seen, if we stay within the state mining permit process, we've seen the opportunity to that publicly what was issued in the last, since say 2021 in Tennessee, there was about 17 state mining permits issued, which are similar to what we're going for, or what we would need. And the average issuance on those permits was about 87 days. So we would like to go in this year, at least for that initial operation, smaller, more capital efficient, and go in for those permits early this year.
What level do you have to kind of get under to be still qualify under a state permit? And when does it become a federal permit or a different permit?
Yeah, technically, it's your interaction with federal waterways. Well, there's a few federal nexuses. There's main one is streams and wetlands. Streams, waterways, wetlands, anything to do with rivers or waters or anything. So we stay well away from any of those. And we're planning operations to have the right buffer zones around any minor streams we see on our properties. It's just we're so big, and this area is so big that there's just no need to affect any of them. So we're just going to stay away from them, even though it cuts the resource out a little bit, and you're not losing much of the resource. So we can stay away from streams and wetlands. That stays away from a federal nexus. The other side is air, the Clean Air Act. And, because we're not a chemical operation, we're not a refinery or anything like that, we stay away from that as well. We don't have we're essentially a mining operation. It's wet sand. There's no real respirable silica in the air because it's all wet. So you stay away from, and you stay well under the thresholds. It's not a large smelter or refinery. So staying away from those two areas, streams and wetlands, and any major impacts to air quality keeps you within the sort of state, mainly within the state permitting process. And administered by the state. And so then it's all about your relationship with the community, your relationship with the locals out there. I'm, personal friends with a lot of the different community members out there. People can see on NBC4, we were featured just last Wednesday in Tennessee. I'm friends with the assistant deputy within one of the states, deputy assistant commissioner within agriculture and natural resources. And, we have a good relationship. Doesn't mean we can do what we want. It just means actually we need to prove that what we've said we're going to do, because that's what locals are expecting of us.
I'm a great fan of doing things right from the beginning, spending your time to get the optimum approach and to kind of do your homework. And you've been talking about various scoping sides of things, and also talking with Energy Fuels about your output, your product stream. I've also seen in one of your presentations you've got kind of pre-feasibility study this year, and next year aiming to do the feasibility study. Are you kind of hung up about those timetables, or are you kind of more focused about making sure that you've got the right relationships and the right agreements with the offtake partners? What's the interaction between those two competing elements?
Yeah, it's a good question. Pre-feasibility study will be next year, and we'll aim to still have feasibility complete next year. In the recent presentation, we were talking around first or second quarter for pre-feas and fees by the end of next year. The main thing in my mind is to be construction ready next year, sometime next year.
Yeah.
And construction ready means engineering studies complete and permitting, the major permits in place. So that's why, for me, typically in a project, as you know, the major critical part, or the critical path in those timelines, is typically your test work and your permits. So my focus has been to hit those, because then the engineering studies, while it's not fait accompli, just, you still got to do them. It is almost sort of fait accompli, because once you have your test work done, you have your flow sheets done, then just doing the engineering work around where you're going to put it, how much it's going to cost, it's just time. But what you're typically waiting for is your hydrogeological studies, your geotechnical studies, and especially your process or metallurgical test work. So we've already initiated a lot of those, and we're into well advanced on a lot of those, especially on our process or metallurgical studies. We're at the feasibility level already, and we expect to have feasibility level metallurgical test work complete well before the end of the year, by October. And then when we turn to the other part, here in the other major timeline, it's typically permits. Here in the United States, there's no real concept of scoping pre-feas fees. They don't really, if you look at, say, Martin Marietta, for instance, which mines a ton of aggregate, hundreds of millions of tons of aggregate, and is always building new operations every year. They never go through, they go through internal studies, engineering studies, but the concept of what we have in say Australia or Canada, they don't have. They go in and they do the engineering studies and permit an operation. So it's all about, do you have enough data there, and do you have enough planning done to submit permits, and do you have the land? We're getting that planning done to submit permits, and we've got the land. That planning typically does not need to be to a feasibility level. It needs to be to a level where you can understand what your impacts are going to be in the region. And we already understand that, both from the work we've done, the feasibility work we've done, the test work we've done, and then, of course, the experience that the team has. So hitting those two things, the major test work campaigns we need to do, and the major permitting process we need to go through, and getting that in and progressing as soon as possible, I think is the major typical hang-ups you see on projects. And if we can get to, say, first, second, third quarter next year and have all that complete, then finishing the feasibility study is finishing the feasibility study.
I think the key element in all of that is keeping the scope the same. So I think the timelines run out when scopes change mid-engineering process, which is it feeds back into when you were talking about permitting. You said if you've got the data, if you've got enough data, then the permitting process can run smoothly. And if you've got the metallurgical test work, then the engineering can run smoothly. It's all about not changing the scope or having to repeat work because you didn't have enough data or didn't have enough test work, or you changed the layout of the plant or the order of the development schedule late in the stage, and that's when the timelines can compound. So it's all about only starting the final stage when you know that that's actually what you're going to study, and you've got the information to dot the I's and the T's on it, cross the T's on it.
And for us, that's why we've taken a pause to get that really down pat and look at what ahead of going into pre-fees, what a capital number would look like for a smaller operation. We also, knowing that process metallurgical test work and the quality of our product is hugely important. That's why we really took the last year or year and a half to get that right with Minerals Technologies, and we brought in some experts from industry to assist us with that. So we have a very good idea of what our product is, and we've already, as you see, secured MOUs across all our major products. And then from a operations standpoint, we feel very comfortable now as we're getting into it what this operation should probably start at, to be both capital efficient, to get us going, and to minimize future potential risks to both the project and to shareholders as well. I think the plan we have is going to be capital efficient, and is going to surprise the market to the upside. Well, I hope so.
Plus, you've got that lovely comparable which you put in a bit of your marketing material in the presentations and things. You've got your annual average EBITDA of whatever it is, 130 million, and the market, million, 117 million, and then you've got the valuation of MP Minerals, MP Materials. They're up at what are they up at? $6.8 billion at the moment. And their EBITDA is what, 80-90 million.
Yeah, you got to also remember, for us, it's a relatively simple operation. So it's unlike, we are lucky we have it easier because this is gravity concentration, and this is mineral separation, physical mineral separation. There's no leaching here. no unknowns. This is the risks are far less than, say, other ore bodies. This is, Mother Nature has already done its work to concentrate and also physically separate out the individual grains of the different minerals. So we're not having to do test work around, acids or alkaline leach or anything like that some of these other commodities, like lithium, for instance, with clays and all that, you really do need to go through a long, drawn-out process to understand how you're going to do it and to minimize your risks there. Whereas this is very simple. It can be, as we hope to show in the pre-feasibility study, can be extremely capital efficient, and the technical risks are very low.
Now, you've got 5 products coming out of this. You've got a rare earth element concentrate. You've got just under 5,000 tons of that. You've got some rutile, some premium zircon, some zircon concentrate, and some ilmenite. The rutile and the ilmenite, that all separates under gravity. Does the zircon? Can you talk to me? Tell me about the difference between the premium zircon and the zircon concentrate. And is the electromagnetic plant, is that the trickiest part of the process?
Yeah. So in the mineral separation plant, you separate out using magnets, essentially, your rutile and your ilmenite, and then you use electrostatics to separate out. Very broadly, use electrostatics to separate out the zircon. And so you can't. It's just how efficient you want to be in the plant, and it's efficient to produce a zircon and then a zircon concentrate. And when you run the numbers, which will run again in the pre-fees, but you run the numbers, it makes sense to sell the zircon con into the international market and that amount of zircon and premium zircon. But that could change as prices for zircon change. I mean, we're using prices in our scoping study which are probably half of what the spot price is today for both titanium minerals and zircon minerals. So it makes sense to sort of separate that out. The important thing, though, I think, Merlin, is that your mineral separation plant is really for your titanium and your zircon minerals. Before you get to that point, like we say, we gravity separate, which is water and gravity separates out the heavy minerals. So your rare earth mineral concentrate and your titanium and zircon minerals. And then you put all the sand back in. You then take that heavy mineral concentrate, and before you even have to bring it to the mineral separation plant, you can float off your monazite and xenotime, so your rare earth minerals. And we've got both. We don't just have the light rare earths, we have the heavy rare earths because we have a lot of xenotime in here. And you can float that off with very high efficiencies from what we've seen already from our test work. And we continue to do test work with minerals technologies in Australia as we speak. And we're actually going to have a small flotation plant in our mineral demonstration facility on site installed in the next few months. But you can float that off, and then you can have this clean concentrate of titanium and zircon minerals that then you could sell that if you wanted to before you build a full mineral separation facility.
Yeah.
And there's quite a large international market for that. There's plants in the US which have got underutilized capacity for mineral separation. And there's plants, in Southeast Asia, which have the same as well, not just China, but like Vietnam and Malaysia as well. So this ore and what we have is amenable to a lot of different options that if you go one route, it doesn't cut you off from adding later. Like we could go just gravity concentration and flotation, sell the titanium and zircon concentrate, have that rare earth mineral concentrate, which today makes up 45% of our revenues, reshore the rare earth supply chain in North America with energy fuels, and sell the titanium and mineral zircon concentrate for the first few years before building the full mineral separation plant. Again, we can be smaller, more capital efficient. We can get into operations quicker, lower technical risk. get through the permitting quicker as well that way. So, you know, there's a lot of options here that if we take one route, doesn't cut us off from adding later, from being more modular later.
Thank you. I understand. Yeah, it does. It makes sense. I understand the process much better now. The rare earth element, the monazite and the xenotime that goes off to energy fuels, does that get processed? Do the rare earth oxides get separated in China, or is there a plan to get them separated in the US?
So eventually? Right now, what Energy Fuels does is they do the first part, which is the cracking and leaching, and they produce a mixed rare earth carbonate that then is sent today. They take a little bit of monazite out of Georgia from Kumul's operations, and they're producing a rare earth carbonate today and shipping it to a plant owned by Neo Materials, Canadian listed, Neo Performance Materials out in Estonia, and they do the separation there. Mark Chalmers, the CEO of Energy Fuels, who I talk to a lot, and we are progressing that MOU into a full-scale, full-blown agreement, hopefully this year. He has publicly talked about bringing separation capacity back home. He's working on his studies in engineering for light and heavy rare earth separation here in America. In addition, you have MP Materials, who theoretically can take that rare earth carbonate once they're building their separation capacity out again, looking to start it up. That's public. And then you also, and they've been funded by I think the DOD gave them money, 30 odd, or the federal government gave them $30 odd million. And then another $120 million actually went to Lynas. And Lynas in Texas is building out both the light and heavy rare earth separation capacity, and again can take that rare earth carbonate that's produced in Energy Fuels today into the Lynas facility. But what I would say is that Energy Fuels publicly, and when speaking with Mark Chalmers, they see the value of doing the separation on site. They do solvent extraction anyway as part of their plant in the uranium and vanadium to separate out uranium and vanadium. So they have a lot of experience there, and they've got a small pilot facility which does it. And I anticipate that by the time we get up and running and supply product to them, that full separation will happen there. So you would have a supply chain of titanium mineral concentrate, rare earth mineral concentrate, comes out of Tennessee, is shipped to Energy Fuels in southern Utah. Southern Utah does full separation of oxides, cracking, leaching, full separation of oxides.
It's amazing, isn't it, that the IP and the technology just was kind of sucked into China, and it just, the West is having to rebuild its know-how. They're having to work out how to separate these elements, which are so physically and chemically similar to each other. There's a real art.
There's an art to it. But, you know, what I would say is that Energy Fuels has been doing solvent extraction now at their pilot facility there for a while. And I think they're well versed in how to do it. And I think you're going to see it happen in the next few years. You're going to see full separation capacity happen and then scale up from there. You know, I think people, it has been hard, but they have the infrastructure there to do it. And then in addition, they have the will, because, you know,
the world's not
feedstock out there. The world needs it, but also with us, you've got a significant amount. Like there's 120,000 tons of defined rare earth minerals already within our deposit, and we're only scratching the surface of what's here in West Tennessee. I mean, there's, as I showed you, there could be many multiples of that. So I think between us and West Tennessee and what we have at Titan, having almost unlimited amounts of rare earth minerals, and then what they have there with existing process capacity for cracking and leaching, which is probably one of the hardest parts to both build, because it's really expensive, and permit. That's already done. That's already behind them. That's $1 billion already out of the equation. I think you have the pieces of the puzzle to bring home rare earth oxide supply a lot quicker than what any of the governments or any of the consumers, like the large auto companies, understand.
Interesting. Talking about kind of onshore metals, and we've spoken. We've had a good old session looking through the scoping study and the titanium mineral side of the business. And that was principally what I wanted to catch up on. What really was after the scoping study. That was kind of the main bulk of it. But I can't help. We can't leave without talking about the metal side of it. The titanium printing. The titanium metal.
Cool.
I see that you've got lots of traction in the kind of the media, particularly in the US. I've read a bunch of articles, including one in the Wall Street Journal last week. I noticed that your ADR sponsor has just put out a kind of a change of ownership, so they've gone to just under 6% ownership of your stock is now in the US, isn't it? And that's following on the back of you've been listed in the Nasdaq for 6 weeks now. So could you just kind of in brief tell me a little bit about the metal side of the business and the traction you're getting in the US?
Yeah, the metal side of the business is really exciting. I mean, people should get excited about Titan, and I think a lot of people do, knowing it's there. You know, the news media came out, NBC came out last week. It was great, and I think we're going to continue to see that. But on the metal side of the business, it more hits home because it's products. It's products that can be printed, using advanced manufacturing methods, which everybody finds cool. We make spherical titanium metal powders today from scrap. We're the only company in the world which makes a 100% recycled titanium metal product. And we're typically taking those powders, and we have 3D printing machines at the University of Utah, both binder jet, and now we have some laser bed powder fusion, small, scale machines for prototyping. We print stuff like we've got stuff like this that we print, Merlin. Like, have a look at that. These little things. We've got a whole bunch of stuff out here that we print just for customer interaction. And these are products that are, instead of it being like a white powder or a black powder that goes into like titanium minerals goes in, makes paint and pigment, you're so upstream, you don't see your product going into something. This is more, we make a powder, we put it into a machine, we print a product, and that product is sold or will be sold by a customer in whether it's in an automotive OEM or whether it's in a consumer goods or consumer electronics brand. So it's the exciting stuff that people can see. Us bringing down that cost of the titanium metal significantly, especially on the spherical powder side, using this advanced manufacturing and starting to bring forth titanium metal into everyday products which people use or a lot of people can see around them, is I think what excites people when we get into the details. And excited Willie Shee, the professor at Harvard who wrote about us in Forbes recently. He calls this the Bessemer moment for titanium, akin to the Bessemer moment in the steel industry in the late 1800s. So I think that's where we get a lot of attention, and that's where we as a company see some major catalysts around some large customers, strategic partners, whatever you want to call them, OEMs, that are going to use our titanium metal products in their products in the near future. And we hope to get those partnerships out soon
and
into the market.
What do you think? You say that could be a catalyst. I mean, because you've announced that you're working with MRL, who's got a kind of relationship with the Department of Defense. You've announced that you're working recently, just a couple of weeks ago, you spoke that you were working with Oak Ridge National Lab, which has got ties to the Department of Energy or Department of Defense.
Department of Energy, yeah.
Yeah. Is that enough? The fact that you've got these kind of alliances with at the federal level, or are you looking at kind of offtake, or when you say kind of catalysts, what do you mean?
Yeah, so I mean big partners, big OEMs, starting to use our titanium metal products starting to use our titanium metal powders to make products that go into their into their products. So our titanium metal powders to make parts that go into their products, or components that go into their products. So that's a big one, because I think the Oak Ridge relationship is fantastic. We're going to develop new alloys for use in a range of applications, and where our process is unique, and we can build or manufacture new alloys quickly and test new alloys very quickly compared to the traditional process. On the MRL side, we're working with the US Navy to qualify flight critical components, and that's fantastic. But again, it's a qualification process for replacement components within the US Navy, and that's great. And I think there's going to be more of those government, specifically DoD related opportunities that are going to come through. But right now, and that's great. It's fantastic. And there's, especially with the recent Inflation Reduction Act that was just passed yesterday or the day before, there's going to be a lot of funding opportunities from the federal government, and there has been for our type of technology, which is sustainable, emissions free, and can promote American leadership in manufacturing. But the thing that I think is going to really excite people is to understand where titanium metal can be used. Look at your everyday products, which are now made of aluminum and stainless steel. If you look at some of the small products and the handheld products and the products we wear, these can all be manufactured using our titanium metal powders going into some sort of advanced manufacturing process, whether it's metal injection molding or whether it's binder jet printing in the future, laser bed powder fusion printing, to make the same component that's right now in steel and aluminum, to make that same component for sometimes lower cost.
But in titanium, which is lighter and stronger.
Which is lighter, stronger, considered a better metal, and it's more corrosion resistant, so it lasts longer. In titanium, if you put it in seawater, it will never corrode. You put stainless steel in seawater, eventually it's going to corrode. So, it's... I think some of these major partnerships which come through can start setting the scene to a lot of people to understand, okay, it's not just pie in the sky. We are producing titanium metal powders today. We are making stuff today using additive manufacturing typically. In the future, we can use other advanced manufacturing methods, but typically additive or 3D printing, as people call it. And in the near future, we can be selling and starting to disrupt the metal sector by selling our titanium metal products into the sector.
Will that be a catalyst for moving to a commercial facility away from the kind of pilot scale? Or are you? So what's the timeline and the plan for that commercial facility?
We're going to put out some updates on what we call our titanium demonstration facility, both on site selection and engineering design and work, and also securing some of the key long lead time items. The furnace, for instance, where the actual hammer process, hydrogen assisted magnetothermic reduction process, actually happens. That's typically the longest lead time item, and we've had some major advancements there. So, we intend in the near future to not just help the market understand which sectors we can really penetrate with our titanium metal powders and make high quality, low cost titanium metal parts, but also the timeline of when we get out there. But it's soon. It's really, really soon.
Taso, thank you very much. It's been an informative session as always. Really, always like really catching up with your news, and good luck ahead.
Absolutely. Thanks very much, Merlin. Speak soon again.